Good day and welcome to another edition, the second episode of this series. We shall be considering series of an AP in today's episode. All right, so remember our series that we're considering this period, the topic we're considering this period is sequence and series. So we have looked at an arithmetic progression or linear sequence in the first and second episode. In today's episode, we are looking at series of an AP. Another name for series is simply sum. So when you are asked to find the series of an arithmetic progression, a linear sequence, they are otherwise telling you to find the sum of that arithmetic sequence. For instance, rather than finding, you're having a sequence of 5, you're having a sequence of 5, 10, 15, and so on and so forth. Rather than summing up the first term to the 120th term and all that, which is going to be tedious, we can develop a formula that will be able to calculate the sum of any arithmetic progression. And how do we do that? Given that the sum of an AP, as we know, is what we find here, a plus d, a plus 2d, till the very nth term, the last term, which is a plus n minus 1d. All right? Now, we will find the sum of all the terms of the AP. All right? Now, let's say that Sn represents our sum. All right? So that means the first one, a, which is here, plus the second one, a plus d, which is this one, plus the third term, which is a plus 2d, plus till you get to the last term, which is Tn. We can call this equation 1. This can be a way a particular student may want to add, starting from the first one to the last term. The person has added all the terms of the AP. Another student may prefer to add from the last one to the very first term by saying Tn, which is the last one. Then, of course, when you remove the common difference from the last one, you're going to have the second to the last. So it becomes Tn minus d. And when you remove another d again, that means when you remove 2d from the very last term, you're going to have the third to the last, which is Tn minus 2d. Then you keep on adding like that till you come to the first term. So equation 1 represents a student who is adding from the first term, getting to the last term, while equation 2 represents another student who prefer to add from the last term until he or she gets to the first term. All right, but both equation 1 and equation 2 are just sum. So which one do we follow? What we now do is to average the formula by adding equation 1 and equation 2. All right, Sn plus Sn will give us 2Sn equals to a plus Tn will give us a plus Tn. All right, that is the sum for this other one. Okay, plus, now when you look at this equation, this is a plus d and this is Tn minus d. D will minus d to give us 0, so you still have a plus Tn again. So you have a plus Tn. When you look at the third one also, this is a plus 2d and Tn minus d. 2d minus 2d to give us 0, still have a plus Tn. All right, a plus Tn. So keep on having a plus Tn, and so on and so forth. So since the number of a plus Tn is unknown, that means we keep on having a plus Tn, a plus Tn, a plus Tn, and other. So that means n will represent the nth term of a plus Tn. All right, so n will now become the number of a plus Tn that you are adding, since you don't know how many a plus Tn that are there. So can I say that that implies that 2Sn is equals to n, the number of a plus Tn that are there, then multiplied by just one a plus Tn. Okay, so that is how we come about this. All right, so when you divide both sides by 2, so you can find your Sn, all right, you're going to have Sn is equals to n over 2 multiplied by a plus Tn. All right, so this will now represent the formula for calculating the sum of an AP. All right, Some other textbook can put it this other way, or remember your Tn is A plus m minus 1d. So you can also have it as Sn is equals to n over 2 into A plus m minus 1d. Okay, where you replace the n and put what it is. Then A plus A will give us 2A. So you can also have that your Sn is equals to n divided by 2 into 2A plus m minus 1d. So these are the two formulae we use in calculating the sum of an AP. What is their use? All right, that's another question. This one is used when the last term is known. That means you know the last term you want to add in that sequence. While this one is used when you don't know the last term in that sequence. Okay, you can also use this one. You can also use it when you even know the last term in that sequence. But of course, it may be too long to remember. So it is easier to remember the first one, this one, then, and of course, since you're already familiar with your Tn, you can replace your Tn to now get this other formula just in case it is difficult for you to remember. So that is a simple way to remember the formula of the sum of an AP. Just remember this one, and of course, from this one, you can always get this. All right, let's consider some example, all right, using this sum formula. Okay, a typical example is given here. Find the series of the first 25 terms of the sequence 11, 15, 9, 23, and 27. All right, so we're asked to find here, we don't know the last term. Okay, this is an infinite series. So we now say our first term is equals to 11. All right, and our second term, our common difference is 15 minus 11 to give us 4. So our common difference is 4. All right, then the number of terms we tend to add is equals to 25 because we should add the series, the addition of the first term to the 25th and the first 25th term. All right, so when I say that our Sn is equals to n over 2, n divided by 2, all right, into 2a plus n minus 1d. Okay, so writing the formula down, we'll now say x25, okay, sum 25 equals 25 divided by 2 into 2 times 4 plus 25 minus 1 multiplied by common difference of 4. All right, 25 minus 1 is 24. And of course, when you times by 4, you have 96. So we invariably have, and of course, you cannot finish up this, all right, to have your sum of the first 25th term, x25, is equals to 1475. So this is how we apply the formula for a sequence that we don't know the last term. Example 2. Here, find the sum of the AP 1, 3, 5 till the last term 101. All right, here we know the last term as 101. So we don't bother using this long formula, though this can also work, all right, but we don't bother using this. This one will work for as much as you know the number of terms, and what we'll now do is to use our sum Sn equals to n over 2 into a plus l. So number of them is unknown, so we need to find that. What's our a? Our a is equals to what? 1. All right, and our l, the last term, is equals to what? 101. So since we don't know the number of them, we can now say that implies, okay, our last term Tn is equals to 101. All right, so we can start to find and say that Tn is equals to a plus n minus 1d. A plus n minus 1d. Okay, where our last term is 101 equals to a is 1. All right, plus n minus 1. Our common difference is 2. Okay, multiplied by 2. If we say 3 minus 1, we are going to have 2. All right, that's our common difference. So when you solve for n, take minus 1 to the other side, you're going to have 1, 0, 1 minus 1 equals to n minus 1 multiplied by 2. So you have 100 is equals to n minus 1 multiplied by 2. Divide both sides by 2. To detach 2 from n minus 1, you're going to have 50 equals to n minus 1. So minus 1 go there. You can now say, therefore, n is equals to 51. So our number of terms is 51. So now say that implies, all right, so now we have our number of terms. We can now decide to use this very formula here, okay, since you know the last term, or we can also refer back to this other formula here, okay. Each of them will give us the sum, all right, so long as we now know our number of terms. So we now say, so but we know that the number of terms has been calculated at 51, so we now say sum 51, all right, is equals to 51 divided by 2 into the first term is 1, all right, then plus the last term, which is 101. Okay, so this is what we have. And of course, when you simplify this with your calculator, you can have the sum 51 to be equals to 2601. All right, so this is the way we solve this. All right, so notice the difference between example 1 and example 2. In example 1, we are told specifically the number of times to which we are summing up, to which we are looking for the series. All right, while in example 2, we are not told the number of times. They ask us to find the sum of the series. Okay, it means that they're adding from 1, 3, 5, and all that to 101. Now, a student who don't understand sum of an AP will be using a very long approach by looking for the common difference, which is 2, and start saying plus 3, plus 5. The next one will give us 7, plus 7, plus 9, plus 11, and all that. Before the person get to 101, of course, other students have finished, the particular, I've solved almost 10 or 15 questions in the examination. Example 3 on this episode. Say the fifth term of an AP is minus 1, and the sum of the first 20 terms is minus 240. What are we asked to find? Find the sum of the first term to the 40th term. Find the sum of the first term to the 40th term. Okay? Now, we're not giving the sequence. Okay? If you look at example 1 and example 2, we are giving the sequence. Look at the sequence here, 11, 15, and all that, where you can be able to extract your A and your common difference. If you also examine example 2, you will see the same thing likewise. We are giving the sequence where we can extract our A, of course, the common difference, and if the number of times is not found, from the sequence you can find the number of times. But in example 3, we are not giving the sequence at all. So if you write the formula Xn, all right, equals to n over 2 into A plus L. Okay, what is your A? What is your last time? You don't know that. All right, okay, those informations are missing. Or if you also write the second formula, Sn equals to n over 2 into 2A plus m minus 1d. Okay, what is your common difference? You are not given the information to start those items. So what it means that you need to go and find the necessary parameter to use in solving this question. So we come back to our general formula for each of the terms, okay, in an AP. The fifth term of an AP is minus 1. So the fifth term is going to give us A plus 4D. Remember, so we now have A plus 4D, all right, because when we say the first time is A, second time is A plus 1D, third time is A plus 2D. So fifth time is going to give us A plus 4D equals to minus 1. All right, we call this equation 1. And it says the sum of the first 20 terms is what? Minus 240. All right, so we now say the sum of the first 20 terms that from the formula here, we have here, from this formula, that x20, all right, is x20, okay, is equals to what? N over 2, which is 20 all over 2, from the formula here, multiplied by what? 2a plus, okay, 20 times, so n is 20, we give us 20 minus 1, then multiplied by d, okay? Okay, so this is equals to what? Minus 240, Okay, so when they did the sum of the first 20 terms, they got minus 240. So when you simplify this, 20 divided by 2 give us 10 into, what next do we have? We are going to have 2a plus 19d, all right, equals to minus 240. Dividing both sides by 10 to remove this 10 from this side, what do we have? We now have 2a, okay, plus 19d equals to minus 24. This will be our equation 2. So now we have equation 1 and equation 2. We can go ahead and use substitution method, okay, as elimination method will not be fast forward. So we solve simultaneously. Okay. Now we'll now say from equation 1, okay, our A is equals to minus 1 minus 4D. All right. This will give us 1B modified. See the equation 1 but modified. So put 1B, all right, put 1B into equation 2. So you're going to have 2 into minus 1 minus 4D, all right, plus 19D, okay, equals to minus 24. Equals to minus 24, minus 2 minus 8D plus 19D equals to minus 24, okay? And we are going to have 11D, all right? 11D equals to minus 22, okay? So therefore, our D is equals to minus 2 when you divide both sides by 11, okay? Now, when you put D into equation 1B, all right? If you put D into equation 1B, put D in 1B, into equation 1B, all right? Now, we are going to have minus 4 times minus 2 will give us 8, and of course minus 1 plus 8 will give us 7. So we can now have our A to be equals to 7. So therefore our A is 7. All right, so this is where we stop for A and D. So after getting your A and D, all right, so what do? You now go now to find the sum of the first to the 40th term. All right, because the initial one they gave was for the first to the 20th term. So we now go ahead and find the sum of the first to the 40th term. We'll now say from, okay, Sn equals to n over 2 into 2a plus n minus 1d, okay? That will now say x40, because we are looking for the first to the 40th term, divided by 2 into 2 times 7 plus 40 minus 1, and our common difference is minus 2. All right, so that is what we have when we substitute, and that will give us 20 into 14 minus 78, okay? Therefore, the sum of the first 40th term is equal to minus 1280. So this is the final answer to that question. All right, so I'm sure that you have understood how we apply the formula of the sum of an AP. It's also called series, okay? We come to an end in this episode. In the next episode, we are going to take further questions on AP to see different questions that would different form of appearance in which question can be. All right. So please, before you go, do not forget to subscribe to this channel, and of course, also hit the bell so that you can also get notification when new videos are uploaded. Like the video. See you in the next episode. Stay put, and of course, stay connected.